Welcome to the Combined Footing Staad Import tutorial. To get started, launch the program. Begin by configuring load combinations. Click the Set Load Combination ribbon button. You'll find two tabs on the form. Footing Sizing Load Combination. This tab is for calculating footing sizes. Make sure you have your Staad file open. Click Extract Load Combination. If the extraction is successful, the data will be displayed in the data grid. Select your desired load combination for the design. Move the chosen load combination to the selected load combination data grid by clicking the right arrow button. The default factor is 1, which conforms to the code. If seismic is part of your load combination, the soil capacity will be increased by 33%. To update the factor, either double-click the data grid and edit the factor or select multiple load combinations by holding the Control key, update to 1.33, and click the Factor Update button at the lower area. To confirm and apply this load combination, click the Accept Sizing Combi button. Footing Design Combination. This tab is used for calculating flexural, rebar, and shear values for the footings thickness. Configure the load combination by clicking Extract Load Combination. If the extraction is successful, the data will appear in the data grid. Select the appropriate load combination for your design. Transfer the chosen load combination to the selected load combination data grid by clicking the right arrow button. To apply the service load combination, click the Accept Design Combi button. These steps will help you set up and apply load combinations for design and sizing checks in your design process. Moving on to the next option on the ribbon, we have Import Staad Reaction, which primarily extracts reaction data for the selected support. Our combined footing supports two columns, the exterior column and the interior column, with a single directional moment supported. When we drop down this combo box, we can choose along X or along Y to determine the moment we extract. By examining our Staad file, if our column aligns with X, we'll choose along X, otherwise, we'll select along Y. Let's consider an example of a combined footing. We'll begin by extracting the reaction data of our exterior column. Select the node of the reaction support. Return to our program and click the Extract Reaction on Exterior Support button. If the extraction is successful, the node number will appear. Next, we'll extract the reaction data of our interior column, following the same steps as with the exterior column. Select the node of the reaction support. Return to our program and click the Extract Reaction on Interior Support button. If the extraction is successful, the node number will appear. The next step is to design our combined footing. Just click the Design All Case button. Our program will provide a design size. If it suggests an impossible design, manually adjust the size of the footing until the ratio between soil capacity and the footing capacity is less than 1, ensuring a safe design. Also, check for wide beam shear and punching shear. Just review the remarks on the Design tab for further insights. Now, let's move on to the reinforcement calculation. Click on the Reinforcement tab. The reinforcement calculation is divided into 7 sections, as indicated on our diagram. The location of the rebar can be determined along this row. For this example, let's check the top location. This occurs when there is bending upward due to positive moment in this area. In our example, along section C, the location of the rebar is at the top. For a safe design, I offset it from the face of the column where the rebar starts. We have 10 pieces of rebar, equally spaced. Next, we have the bottom location, which applies to sections A, B, D, and E. In our design, we use 10 pieces along sections A and B and 12 pieces along sections D and E. We can arrange the rebar in 2 ways. One option is to place 10 pieces all along the longitudinal direction and add 2 extra bars in the column area to meet the required 12 pieces of rebar. Alternatively, for simplicity, we can put 12 pieces evenly along the longitudinal direction for added safety. Moving on to the transverse direction, our calculation indicates a width of 510 mm. We place 3 pieces of rebar equally spaced at the column area. For proper bonding of our rebar, we can include additional temperature bars with a maximum spacing of 200 millimeters. Many thanks for listening, and may you always be blessed by the grace of God.